This is Algebra 1, Lesson 8D, Areas of Circles. We've learned a little bit about circles. Let's review a few terms. We know that the center is this point in the middle that is equidistant from the edge of the circle all the way around, and that equal distance all the way around from the center out to the outside of the circle is called a radius. So we can label this little piece as an R, as a radius, and we can label the point as a C for the center. That diameter would be, if you go all the way through the center, it's like you've got a radius and then you keep going to the other side, that entire piece would be a diameter. So it's 2 radii makes a diameter, or half of a diameter makes a radius. Then we learned about circumference. Circumference is the distance all the way around the circle. So circumference would be this orange area out here, and we learned a formula for it. We learned that circumference is equal to pi times the diameter, or we wrote it as 2 pi radius. Either way, because remember we said that a diameter is 2 radii. So you could replace the D with the 2R. So those are the things we've already learned about circles. Now, when we came across other shapes that we don't know how to find the area of it in previous videos, we've cut the shape up and tried to reassemble it to where we make it into shapes that we do know. And you can do that also with a circle, but it's a little bit messy. So we're going to use Geogebra to help us with this. Okay, here's our Geogebra demonstration. We've got a circle and we've got it cut up into eighths. Now let's talk about the colors for a second. The red here shows half of the circumference. We already know that circumference is 2 pi times the radius, or 2 radii times pi, right? So the red part is only half. So half of 2 pi r would just be 1 pi r, and that's why you see that here at the bottom of your screen. They also show the length of the radius, okay? Now we've got 8 cuts here. Watch what happens when I tell it to unfold the circle and then slide those pieces together. The whole circle is still there. It's just cut up and shifted to try to make it look into a shape that we know. Now, to me, this looks kind of like a weird parallelogram, which we haven't even gotten to yet in our review, but it also could look like a sort of like a rectangle if it were squished over, right? It doesn't have 90-degree angles. So let's take it back and let's make more cuts. So let's tell it to make a few more cuts. Now let's unfold it and let's bring it together. It's getting closer and closer, looks more parallelogramish to me, except for it's still got these little wavy things here. So let's take it back and let's tell it to make more cuts. Let's unfold it, put it back together. Look how close that's looking to a rectangle now. Let's do it again. Lots of cuts. This would be hard to do with pencil and paper, wouldn't it? Okay, it's looking really close to a rectangle now. Let's take it as far as it'll go. Unfold it. Do you see how much that looks like a rectangle? Well, you could find the area of a rectangle. We just talked about that, right? You would do the length times the width. Well, the length here is pi r, and the width is r. So pi r times r would be pi times r, or pi times r squared. And that is actually the formula for the area of a circle. Pretty cool. I'll put the link to the Geogebra demonstration in the description box for this video, and you can try it for yourself. It really is cool to be able to play with it a little bit and try that, and you can convince yourself how they get the formula for the area of a circle. Area is equal to pi times the radius squared. This is a really helpful formula for finding the area of a circle, because you know counting all those little pieces of squares would not be very accurate, nor would it be easy.